Hey everyone, and welcome. Today we are diving deep into something most of us use every day, but probably don't think twice about: the Iranian elevator standard, ISIRI 6303. This is the invisible rulebook that keeps our vertical journeys safe, and we're about to break down exactly how it works.
So, really think about it for a second. Every single time you step into an elevator, you are putting a whole lot of trust into a very complex machine. But what is that trust actually built on? Well, it's definitely not just wistful thinking. It's a super detailed, meticulously engineered set of rules. So let's start with that very idea, the foundation of trust. Our confidence in this technology is no accident. It is carefully built on rigorous standards that guarantee safety right from the very beginning. Now, what's really interesting is that Iran's key safety standard, ISIRI 6303, wasn't just created out of thin air. It's actually directly based on and harmonized with the globally recognized European standard, EN 81. This is a huge deal because it means Iran's standard is built on decades of international experience and best practices, all adapted into a powerful national framework. Okay, so let's get into the nitty-gritty. We're going to peel back the layers of this technical blueprint and look at the specific rules that control everything, from the elevator shaft itself to the cabin you're actually riding in. You know, safety really starts with the space the elevator moves in, the well. The standard is incredibly specific here. It demands clear escape spaces for technicians, both above the elevator and in the pit below. The walls have to be non-flammable, and all the dimensions are precisely calculated based on the elevator's capacity. It's all about creating a totally secure environment before anything else happens. And what about this number? Plus 25%. This represents a critical safety margin. The standard mandates that the cabin floor has to be able to handle its maximum rated load plus an extra 25%. This ensures it can take on any unexpected stress without even a hint of a problem. All right, now for the safety features we actually see and interact with. Every sliding door must have a manual emergency unlock. But even more important are the mandatory light curtains or photocells. These create an invisible safety net across the doorway, preventing the doors from ever closing if anything or anyone is in the way. And of course, the standard ensures accessibility, making elevators safe and easy to use for everyone. Meet the elevator's ultimate guardian angel. The overspeed governor is a mechanical device, and its only job is to constantly watch the cabin speed. If, for any reason, it senses the elevator is going too fast, it mechanically trips a switch, and bam, it engages the safety gear. This is a super powerful braking system that physically clamps onto the guide rails and brings the cabin to a complete and safe stop. The entire electrical system is built around one brilliant idea: the fail-safe principle. So what does that mean? It means if any part of the safety system fails, like a wire breaks or a switch gets stuck, the system doesn't become dangerous. Instead, it's designed to automatically default to its safest possible state, which is, you guessed it, stopping the elevator. So a great design on paper is one thing, but how do you prove it works in the real world? This next part is all about the intense testing that turns that blueprint into a certified safe reality. This quote right here highlights a crucial layer of protection. See, it's not enough for a manufacturer to just say, yep, our parts are safe. No way. Every single critical component, the door locks, the brakes, that overspeed governor we just talked about, they all have to be independently tested and certified by an accredited lab. This gives you verifiable third-party proof that these parts can be trusted. The approval process is absolutely a marathon, not a sprint, with checkpoints at every single stage. It all starts with checking the initial design, way before anything is even built. Then, the parts are tested at the factory to find any problems early. Once everything is on site, the entire system is tested to make sure all the components work together perfectly. And only after passing every single one of these stages can it finally get that stamp of approval from a certified Iranian inspection company. Now, while ISIRI 6303 is built on that international EN 81 standard, it's not just a copy and paste job. There are very specific adaptations made for the conditions and priorities right here in Iran. Let's look at a few of the key differences. For hydraulic elevators, their use in Iran is restricted in buildings that are taller than 4 stories. And this is a big one. Emergency power systems aren't just a nice-to-have recommendation, they are mandatory. This ensures that elevators keep working even during a power outage. Also, special designs like those cool panoramic or machine roomless elevators, they face extra scrutiny and need special permits to get the green light. So, let's say you're an architect, a builder, or a project manager. How do you put all this into practice? Well, this final section is your practical checklist, your path to full compliance. Following the path to compliance really boils down to 5 essential steps. First, you figure out exactly what the elevator is for and what its capacity needs to be. Step 2 is non-negotiable. You have to use only certified components. Now, step 3 is maybe the most important piece of advice here. Get an inspection company involved from day one. This will save you so much trouble later. With their help, you get all your technical documents pre-approved before you install anything. And the final step, of course, is passing all the safety tests to earn that official certification.
At the end of the day, ISRI 6303 really shows us that safety isn't just an optional feature you can add on. It is the absolute foundation that public trust is built on. So the real question it leaves us with is, whether we're talking about elevators or any other part of the world we build, are we making sure our foundations are truly solid? Thanks so much for watching.